All right, so in order to be a chemist, you have to know how to talk like a chemist, and that comes through nomenclature. How do we name these compounds? And so this isn't the most fun part of the course. It is a bit tedious. It is a bit work intensive, but we got to get it down if we want to get to the exciting parts. So let's learn how to name compounds. The first thing we're going to start off with is our ionic compounds that we learned about a bit already. So remember, in ionic compounds, they're made out of a metal plus a nonmetal, and there's a transfer of electrons. So that's what this picture shows right here. On the left, we have a sodium ion, a metal, and then a chlorine, a nonmetal. They combine, the electron goes from the metal to the nonmetal, and then we form an ionic compound, sodium chloride or table salt. So we'll look into that deeper later on, but for now, we want to focus on the nomenclature. So remember, this is a metal plus a nonmetal, or a polyatomic ion instead of the nonmetal. Remember that the electrons are transferred. And so for now, we're just going to focus on group 1 and 2 and aluminum as our metals. So these are all fixed charge metals. Remember, everything in group 1 is always +1. Everything in group 2 is always +2. And for us, aluminum will always be +3. So the way these things are named, it first comes the name of the cation, which is the positively charged component of the compound, so the metal. And then after that, you name the anion, except on the anion, you add the word "ide" instead. So you cut off the ending and you switch the word to "ide." Only if it is not a polyatomic ion. If it is a polyatomic ion, then you don't change the name. So you just go the name of the cation and then the name of the polyatomic ion. So this stuff is best done through practice. We'll spend some lab time on it, but let's do a little bit of practice first here. So we have NaCl, right? And this makes sense. Sodium is in group 1, so it's going to want to be +1. Chlorine is is a halogen, so it's going to want to be -1. So +1, -1 makes sense that they're in a 1-to-1 ratio. And so we start off by naming this the name of the cation. The Na is sodium. And then chlorine is, or Cl is chlorine. And then we change the ene to an ide. So this becomes sodium chloride. Next up, we have MgBr2. And again, this makes sense. Magnesium is going to be +2. Bromine is going to be -1. So overall neutral, we're going to need 2 bromines. And so since we know that magnesium is always +2, we don't have to tell you how many magnesiums there are. We assume that you can figure it out. So the name of this would just be magnesium bromide. There's no indication of how many of each element there are. We assume that you're knowledgeable in chemistry, and so you know magnesium is always +2, bromine is -1. Thus, when we say magnesium bromide, we assume that you know it's MgBr2. Another example, Li2O, right? Li is going to be lithium. O is going to be oxygen, so that becomes oxide. Sodium oxide. Something like NH4Cl. What you have to do here is you have to be careful and you have to recognize that NH4 is a polyatomic ion and it's ammonium. So NH4Cl is going to be ammonium chloride. Let's do some examples of the reverse way. So let's see, sodium phosphate, barium oxide, barium fluoride, sodium oxide, and then aluminum oxide. So let's figure out what each one of these are. If you know this, go ahead, pause the video and work through this. Let's work through this one ourselves, and then everybody can pause the video. So sodium is Na. It's in group 1, so it's going to want to have a +1 charge. Phosphate is a polyatomic ion, and it's PO4 3-. So if we think about how we're going to balance the charge here, well, one's +1, one's -3, so we're going to need 3 of the +1s. So it's going to be Na3 PO4. That's sodium phosphate. So go ahead, pause the video, work through these, and then replay it to make sure that you're right. All right, next up we have barium oxide. We find barium Ba down here, part of group 2, so it's always going to be +2. Oxide is oxygen, so that's 2-. Like those cancel out, so barium oxide is just BaO. Again, we have barium 2+. Here, fluoride is just F-. Combine these two together. We're going to need 2 fluorines for every 1 barium, so it'll be BaF2. Sodium is +1. Oxygen is -2. So now we're going to need 2 sodiums for each oxygen. So Na2O. Next up, we have aluminum. Aluminum is going to be +3. And then oxygen is 2-. So when you're figuring out what these need to be, a little trick is you can take these charges and just kind of put them in the subscript instead. And then make sure you reduce to the lowest common numbers. So for example, the Al, since the oxygen is 2-, we can put a 2 on the subscript. And then since the aluminum is +3, we can do O3. And there's no common factor between 2 and 3, so it's already reduced as much as we can reduce it. Let's just do another one of these examples, one more. Calcium phosphate. So go ahead, try the trick and figure it out. All right, so hopefully you pause the video. So calcium is calcium 2+, phosphate is PO4 3-, and so we can just kind of move the charge into the subscript. So there's going to be 3 calciums, and then in the phosphate, since this is all one polyatomic ion, we have to put parentheses around the PO4, and then there's going to be 2 of them. So overall, in this formula, we have 3 calciums, we have 2 phosphoruses, and then we have 8 oxygens. Make sure you understand that and make sure you understand this notation. Here's just some common compounds that you have. You want to go ahead, pause the video, look at the names, and make sure that you understand the names and understand why they have the name that they do. I know nomenclature is not everyone's favorite component of the course, but it is important.